Well, hello guys, here Mr. Yi with another video. This time it's going to be a video for the grade 12. This is a question 9 done in the Eastern Cape in 2023. But before we carry on, don't forget to subscribe for the channel and like the video so you can get all the notifications and videos I post on a regular basis. Shall you need something else? Just ask me and I'll make a video for you specifically. This question said a coal power station uses alternating current generators to produce electricity. State the energy conversion that takes place in a generator. And guys, remember, in a generator, the conversion is mechanical energy is converted to electrical energy. So mechanical energy converted to electrical energy, and you'll get 1 mark for that. No, instead you get 2 marks for that. Quite simple, guys. It's very simple to get those 2 marks. Okay, you need those 2 marks. It's 12 marks for the whole question. Draw a sketch graph of EMF generated versus time for 2 complete cycles for a AC generator. Remember, this type of graph will be either a sine graph or a cosine graph, either one. But in this case, they want you to do 2 complete cycles. Okay, so let's quickly do that graph roughly here. This one is question 9.2. okay, so the one EMF versus time. So this is going to be the axis. This is time, this is EMF, and EMF is in volts. They don't want numbers, they want the sketch graph here. So when you draw the graph, be careful. I'm going to draw a sine, but you can also draw a cosine. I'm going to draw there. This is roughly drawn, and this is 1 cycle there. They want 2 cycles. So from there I continue, and I'm going to draw, this one is too high. I'm going to draw another cycle. It doesn't need to be beautiful, it needs to be correct. And that is the 2 cycles. If you do that one, which I am sure you can do it, you will get 1 for the correct shape. Correct shape means either sine or cosine. And then you get another mark for having the 2 complete cycles. No 1, no 1.5, but must be 2 complete cycles. Be careful with that one. It's another 2 marks. Quite simple to get. Question 9.3. Alternating current is used for a long distance transmission of electricity. Give a reason why AC is preferred over DC to transmit electricity over long distance. Guys, there's a long list of why it is better AC than a DC. It's a long distance for that, long list of that one. I'm going to mention perhaps only one of them, but there is a big list of them. Maybe I'll post it there. Okay, and these are 3 examples. It's easier to be transformed. When we say transform, means step up, step down. For instance, you can take easily 220 volts and convert it to 12 volts. That is quite simple. You make a transformer, you get 12 volts and you make it step up to 24 volts. It's quite simple to transform. That means by transform, it is going either up or down in terms of a potential difference. It is easier to convert to DC. So you get AC and you can convert it to DC easier than the other way around. And it's easier to generate. But this is more important or more easier thing why it is rather use AC than DC. I will post the whole of them. 9.4. An electrical kettle is marked 220 volts. What does the 220 volts represent? And guys, just to continue with the trends of marking, there's 1 mark for if you say any of those. Okay. So what is the 220 volt represent? And you must know that 220 volts represent the root mean square. That is V root mean square. I'm going to write it with a symbol. It is not the maximum voltage. It is the root mean square voltage. And just for saying that, you get another mark. Guys, so far all the marks up until here are quite simple, very easy to get. So you already will get 2, 4, 5 and 6 marks, which is half, 50% of the question by not doing any calculation. Okay, now question 9.5. A certain AC generator produces a peak current that means maximum current. So let's write it here just for control. That peak current means maximum current. So that is the maximum current. Let's Maybe fix that word. Maximum current is equal to 6,25 ampere. It's a very small generator. When connected to an electrical kettle of resistance 45 ohm. The resistance of the kettle is 45 ohm. R is equal to 45 ohm. Alright, calculate the root mean square for the current. Guys, please go to the formulas. It's very simple. Those are the 3 marks. So let's go to the formulas real fast. And see here, all the formulas related to alternated current. This is the formula, very simple, to calculate the root mean square current. Current maximum divided by square root of 2. Please, that is a very simple formula for you not to make mistake. We can even do it here at this point here. The current maximum, the root mean square is equal to current maximum divided by square root of 2. If you substitute, is 6,25 divided by square root of 2. When you do that, you will get 4,42 amperes. That is the answer. So it is another 3 marks by that simple calculation. And then it's only the final, the power dissipated by the kettle when connected to this generator. And is also quite simple. Once more, as usual, right with the data you have, you will have enough time if you do this. So this one is question 9.5.2. What do we have? We have the root mean square current, which we just calculated, and is equal to 4,42 amperes. We have the resistance of the kettle, which is given to us, and is 45, I think, 45 ohm. There we go. 45 ohm. And we also have the current maximum. Let's write the maximum current. Maybe we don't need it, but let's write it. Let's write it just in case. It was 6,25. 6,25 amperes. We're looking for power, average power. And this is very important something. This average here is quite important because you may lose mark if you don't write that little letters there. So let's go to the formulas, guys. Let's go to the formulas and look here. Here is the formulas for power. Look there how many formulas you have for power. Now be careful. The little letters, they are quite simple. I think they call it a script. Those letters are extremely important. If you don't write those letters there in the formula, you lose 1 mark. Okay, you don't get that mark. You won't get 0, but you will lose that mark. So we're going to use that one because we have everything. So we're coming back here to this point of the question. We have only one more question to go for this question paper. We say power average. Be careful, I've been marking, I know you lose the marks. Now this one is equal to a current root mean square multiplied by resistance. Okay, so now all you have to do is to substitute. Average power is equal to 4,42 square multiplied by 45, which is the resistance. Average power is equal to 879,138. Let's leave it like that. And then what is the unit? This is the final answer. Is another very easy question. I am sure in this specific question you all can get 100%. You all can get 100% there. One for the formula, one for the substitution, one for the answer. This is the end of the question as well as the end of the video. I really hope you understand and then you get more clarity of how to get marks in this specific topic. Next time, don't miss the video. Next time we're going to be doing a Doppler for the electric effect, which could be confusing for some learners. It is only 13 marks and it's the last question of this question paper, except for the multiple choice, which I'm going to make a plan about multiple choice. I want to start practicing paper 2 as soon as possible because that is the big problem one. But thank you for watching. Thumb up, subscribe for the channel, write messages if you want. I'll see you next time. Mr. G here.